Okay, so I want to do a very quick video about a common misunderstanding that I've found that a lot of students have about PDAs. So what I'm going to do is I'm going to demonstrate a PDA for this language here. Let's just take a look at it. It's got a bunch of A's and B's. It has to have at least one A, right? Because n is greater than or equal to 1 for the number of A's. And it also has more A's than B's, or at least as many A's than B's, right? So you can't have more B's than A's, but you can, in fact, have 0 B's, okay? So that's my language. And if we look at just some examples of some strings that are in the language and not in the language, we can have, remember, it's more A's than B's, or at least the same number of A's and B's, or more A's than B's. So all of these strings here are in the language. Lambda's not in it because you have to have at least one A. B's not in it because there's no A's and we have to have more A's than B's or the same number. And here's some more strings that aren't in that language. So what I want to do is show you a JFlap PDA that I made for this language. So look, what do? If I see an A, and there's nothing on the stack, right? The stack is empty, then I'm going to push a Q. And if I see an A and there's a Q on the stack, I'm going to push 2 Qs. And I take this lambda jump to get between the sort of A processing and B processing. I can only take the lambda jump if there's a Q on the stack already, because I want to make sure I have at least one A. And then as long as I have Q's on the stack, I can pop them along with my B's. Okay, so if we real quick take a look at the multiple run, let me make this a bit bigger. Here's all the examples I showed on the slide, and if I run all of these, accepting by final state, it does indeed accept all the ones that have at least as many A's than or more A's than B's, or the same number of A's and B's, and ones that don't match the appropriate pattern, it doesn't. But what I want you to see here really is not this multiple run, but I want to do a step by state. And the reason I want to show you this is the whole point of this mini video or whatever is the following. Here's how we defined PDA acceptance, right? A string is accepted if there's some path from the start state to a final state that consumes all the letters in the string, right? And the thing that's not written on this slide that confuses a lot of students that I really want you to remember is it's okay if there are letters left on the stack. We don't care. Nowhere in here does it say you have to empty the stack. It just says that you have to use up all of the letters in the string and having a path through the PDA. So let's take a look at our JFlap file again. Here we go. If I'm doing step by state, and let's try something like lowercase AAAB. I'm going to accept by final state. If we watch what's going on down here in our simulation, we start with just a Z on the stack. We process that A and put the Q on the stack, right? That's the first A. Process the second A, and of course when we process the second A, we have two options. We could take the lambda jump over here, or we could we take the lambda jump. We don't actually process the A yet, but we're going to fall off in a minute. Or we could process the A here and use it up. So this is going to live. This one's going to fall off in a minute. We do another step, and there's the one that just died. Here's another one. Notice you see it's at Q1. It's about to die. This is the path that's really actually getting taken, the successful path. We take another step. Okay, this one fell off. Over here now, though, we've gone A, and our lambda jump, and we find ourselves at Q1 with this one, right? And now we see the letter B, so we're going to take this loop up here. And when I do that step, we use up the final letter in our string. So we've processed AAAB. QQZ is still on the stack. We only popped one Q for that B. Nevertheless, we got green. It's okay, we accept. Why is that? Because we accept if there is some path through that allows us to get through using all the letters, and we don't care what's on the stack. So really, all you need to remember from this video is it's okay if there are letters left on the stack. That has nothing to do with whether you accept a string or not.